I'll read the problem on Poisson distribution here. So how to identify Poisson distribution problem? So remember here they will start with an average. In the problem, average or mean value will be given, and the event. Yesterday I said the examples where there is no limit or it is uncountable or unpredictable how many times that event may repeat or occur. Okay, for example, road accidents. One cannot imagine how many accidents will occur. On an average, it can be said by seeing the previous observations. So last week 10 accidents took place. So on an average 1.3 accident takes place, that we can tell. But today how many accidents will occur, that one cannot tell here. So, and I'll read the problem. A typist makes 2 mistakes per page on an average. So the term on an average. A typist, while typing, he makes 2 mistakes per page on an average. So that means he may make more than 2 mistakes also. He may make less than 2 mistakes also, or even he may not make any mistakes. So all things are possible here. So no mistakes, 1 mistake, 2 mistakes, or maybe more than 2 mistakes are possible. So on an average, average means mean. So parameter of Poisson distribution is lambda is equal to 2. Lambda is 2. Then find the probability that a page typed by him has 2 mistakes. So first question, 2 mistakes. So the page which is typed by him has exactly 2 mistakes. Okay, so it is easy to solve. Then second question, at the most 2 mistake. At the most 2 mistakes. At the most 2 mistakes. So at the most means maximum 2 mistakes he may do, not more than 2. So not more than 2 means less than 2. 0 mistakes also he may make, that means no mistakes, and even 1 mistakes he can commit while typing. Okay, and 2 mistakes also. So at the most means up to 2 mistakes he can make, 0, 1, 2. Okay, let us solve here one by one. So first we have to define x. So x takes number of mistakes per page. X, number of mistakes per page. Then x is x tends to Poisson distribution with the parameter lambda is equal to 2. So lambda is equal to 2. Then probability mass function PMF. PMF is P of x is equal to e raised to minus lambda raised to x divided by x factorial, where x takes 0, 1 till infinity, and here P of x is equal to e raised to minus 2 and lambda raised to 2 divided by 2 factorial. X takes 0, 1 till infinity only. So don't limit it to 2 here. So average is 2 means it go beyond 2. So till infinity. Now come to first question. So first question is 2 mistakes. So here he commits exactly 2 mistakes. So first question, 2 mistakes. So 2 mistakes means P of x is equal to 2 is equal to P of 2. So P of 2 mistakes is equal to e raised to minus 2. Sorry, e raised to minus 2 here. So e raised to minus 2 into 2 square, that is 2 raised to 2 as x is 2 and divided by 2 factorial, 2 into 1, and p of 2 is equal to e raised to minus 2. So let us check the table value for e raised to minus 2. So in the table, go to from the first column lambda, go to number 2 there. So exactly 2 is there, no 2.12 like that. So 2 immediately next column, that is the 0.1353. So value for e raised to minus 2 is 0.1353 into 2 raised to 2 is 4 divided by 2 factorial is 2. So 2 ones are 2 twos are. So P of 2 is equal to P of 2 is equal to, we get 0.2706. So probability of getting exactly 2 mistakes is 0.2706. So that is the answer for first question. Now suppose if he has given number of pages in the book, we don't know how many pages are there in the book, so we are assuming that he makes 2 mistakes per page. If suppose 500 pages are there in the textbook, so in how many pages he will make 2 mistakes? Then multiply 500 to this answer. So we will get exactly in how many pages in the book he makes 2 mistakes. Okay, such questions will come later. And now come to the second question. At the most 2 mistakes. So I will rub this. Now second question. At the most 2 mistakes. So that is P of x is less than or equal to 2. So that is equal to P of 0 plus P of 1 plus P of 2. So here x takes 0 to infinity. So we cannot go beyond it. So even we cannot calculate 1 minus like that. So P0 plus P1 plus P of 2. So P of x less than or equal to 2 is equal to P of 0. So e raised to minus lambda into 2 raised to 0 divided by 2 factorial. That we know already that probability of first term P of 0 is e raised to lambda itself. So let us write that directly. So e raised to minus 2 into probability term for first, P of 1, that is second term is e raised to minus 2 into 2 raised to 1, that is lambda 2 itself, plus P of 2 e raised to minus 2 into 2 raised to 2 divided by 2 factorial, that is 2 into 1. So that answer already we got. So here e raised to minus 2 is 0.1353 into again 0.1353 into 2 plus this answer already we calculated, and that is 0.2706. 0.2706 here plus. So the answer 0.1353 into plus 0.2706 plus 0.2706. So final answer is 0.6765. 0.6765. If we add all these three, we get 0.6765. That is, in a textbook, less at the most, that is maximum 2 mistakes we can find in the probability is 0.6765. Next question on Poisson distribution. The probability that a knife manufactured by a firm is defective is 1 by 50. Okay, 1 divided by 50. This is a different kind of question. Here he has not given average. Remember, it is not an average. The probability that a knife manufactured by a firm is defective is 1 by 50. So, if whatever number of knife the manufacturer manufactures, so from that 1 among 50 will be defective. So, if suppose he manufactured 100 knives, then 2 will be defective. Suppose if he manufactures 1000 knives, then 20 will be defective. So 1 by 50 is nothing but P of binomial distribution. So this problem is extending from binomial distribution to Poisson distribution. So here P is given. So but here we cannot calculate this problem with help of binomial distribution. So we are going to Poisson distribution here. So let us continue. Knives are supplied in a box of 50 each. So these knives, whatever knives they are manufacturing, they are supplying in a box of 50. That means one box contains 50 knives in a lot of 1000 boxes. So each box contains 50 knives. Such 1000 boxes they are made and they are supplying. And in a lot of 1000 boxes, how many boxes contain 3 defective knives? So first question, 3 defective knife. 3 defective knives. Second question, at least 1 defective knife. At least 1 defective knife. So at least means minimum 1 defective knife. More than 1 defective knife they are expecting. So this is the question. Now here, now we don't know the lambda here. We don't know the lambda. We know P, probability of binomial distribution. Okay, then what is the N? That is the binomial distribution has 2 parameters. One is N and another one is P. So if P is 1 divided by 50, then what is N here? So N is that the knives are supplied in a box of 50 each. So in a box they are packing 50 knives. That means N, small n is 50. So we cannot calculate for 50. So it has taken a large number. So it is going to Poisson distribution, and even the probability of success, that is we are getting the counting here defectiveness. So if we find defective, that is a success for binomial distribution. So probability of success is very small. Probability of success is very small and n is very large. It's not infinity, but it is not a small figure also. So P is small, n is large. So we take it into, so P is small, n is large. So we take it into Poisson distribution. So let us calculate it step by step. So first, X takes, and 1000 boxes we are supplying, that is capital N. 1000 boxes are capital N. Now X takes number of defective knives. Number of defective knives in a box of 50. So not from manufacturing lot. So we are taking here from the lot of box, that is 50 units box. Then X tends to binomial distribution. x tends to binomial distribution with the parameter n is equal to 50 and p is equal to 1 divided by 50. So n is equal to 50 and p is equal to 1 divided by 50. So here since 50, n is 50, it is not a small number and p is very small. Write that point here. Since n is large and p is small, x is treated as Poisson variate. So here x is treated as a Poisson variate. Then the parameter of Poisson distribution is lambda. So lambda is, then x tends to Poisson distribution. Poisson distribution. Before that, first let us write mean. Then Poisson distribution parameter. Parameter lambda is equal to np is equal to 50 into 1 divided by 50 is equal to 1. So lambda mean for binomial distribution and also for Poisson distribution is 1. Now x now tends to Poisson distribution with the parameter lambda is equal to 1. So PMF, then PMF is p of x is equal to e raised to minus lambda raised to x divided by x factorial. X takes here 0, 1 till 50 or infinity also we can write. Now first question. So first question is 3 defective knives. So 3 defective knives. First question, 3 defective knives. So P of x is equal to 3 is equal to P of 3. So P of 3 is equal to e raised to minus 3, e raised to minus 1, 3 raised to 1 divided by 1. Parameter is 1, no? So e raised to minus 1, 1 raised to 3 divided by 3 into 2 into 1 is equal to e raised to minus 1. So e raised to minus 1, table value for e raised to minus 1 is 0.3679. 0.3679. So 1 raised to 3. So 1 raised to 3 is 1 itself. So into 1 divided by 3 into 2, 6 into 1, 6. That is equal to, so here 0.3679 divided by 6 is equal to 0.0613. So approximately 0.06. The probability of getting exactly 3 defective knives is 0.063. The second question is at least 1 defective. So at least 1 defective knife means 1 defective means more than 1 greater than or equal to 1 defective knife. So it takes 1, 2, 3 till 50. So up to 50. At least 1 means up to 50 defective items. So here calculating a 50 for probabilities is not easy. So what we do here, first probability term 0. So these all we have to calculate, and we know that probability of all, if you add, that is summation of p, probability of all x values is equal to 1. So if we include this also, that becomes 1. Then 1 minus p of 0 if we do, we get probability of remaining all, that is at least 1. So what we do here, 1 minus probability of 0. So second question, at least one defective knife. So that is P of X is greater than or equal to 1 is equal to 1 minus P of X is equal to 0. So P of X is greater than or equal to 0 is equal to 1 minus P of 0, that is equal to 1 minus P of 0, e raised to minus 1, 1 raised to 0 divided by 0 factorial, or directly e raised to minus 1. So 1 minus P of e raised to minus 1 is that we got the answer 0.3679. 3679. So the answer is 0.3679 minus, if you deduct it by 1, 0.6321. The probability of getting at least one defective is 0.6321. Now the question is, in how many boxes we get at least one defective? So then multiply this n into P of X is equal to, n is 1000 into 0.6321, that is equal to 632.1, approximately is equal to 632 boxes. So in 632 boxes we get at least one defective article. Page number 203, problem number 80. I will read. Out of experience, it is known that 1% of screws manufactured by a firm are defective. So 1% is equal to 0.01. 1% of screw manufactured are defective. So that 1% is nothing but what here? P. It is not an average. So it is from the experience. It is identified in percentage. Screws are supplied in a packets of 100 each. So these screws are supplied in a packet of 100 each. What is the probability that a randomly selected packet has 2 defective? So a randomly selected packet has 2 defective. So probability of P of 2. So first question is P of 2. And the second question what he has asked, among 3000 packets, in how many packets would you expect defective screws? So here 3000 packets. A packet contains 100 screws. Such packets total 3000 packets. Among 3000 packets, in how many we are expecting 2 defective? Sorry, totally defective screws. So first question is very easy, that anybody can solve. So that is direct question, 2 defective screw. Now the question here is, second question I am reading and I am going to solve the second question only. Among 3000 packets, in how many packets would you expect defective screws? So defectives means whatever number, all 100 may be defective, 50% may be defective, or only 1% may be defective. Okay, if packet contains 1% defective means in how many packets among 3000 we are getting defective? Means here defective we cannot identify, but we can identify non-defective items, that is 0 defective. Okay, so same thing here, 1 minus non-defective probability for non-defective screws packet. Then we can identify number of defective items. Okay, so because 3000 packets, in each packet 100, that is impossible. Now first here we need to identify lambda. So how to get lambda? So this is P. This is not an average. If the question is on an average, then it would have been lambda itself. But here what he has given? Percentage. That is P. P is 1% or 0.01 or 1 divided by 100. And 100 is N. 100 is n, then lambda is equal to 100 into 1 divided by 100 is equal to 1. Okay, so all the time we don't get the same thing here. So sometime 200 may be given or 50 may be given. So lambda calculation is must. Understand it and solve it. Okay, now x is a number of defective screw in a packet of 100. Then x tends to binomial distribution with the parameter n is equal to 100 and p is equal to 1%. 1%, and here probability of success 1% is very small and n is very large. Since p of n is large and p is small, x is considered as a Poisson variate. Then the parameter of a Poisson distribution lambda is equal to n into p is equal to 100 into 1 divided by 100 is equal to 1. So lambda is equal to 1. Then the probability mass function of Poisson distribution is e raised to minus lambda raised to x divided by x factorial. Now the question, second question I am solving directly here. So that is among 3000 packets, how many packets would you expect defective screws? So how many defective packets? So that is p of x is equal to 1 minus p of non-defective, probability of defective. So I will write it once again. Probability of x is equal to defective is equal to 1 minus probability of non-defective. So that is p of x is equal to 1 minus p of 0. So 1 minus p of 0 is e raised to minus lambda itself. So minus 1 minus p raised to minus 1. So e raised to minus 1 is 1 minus 0.36. E raised to minus lambda is 0.3679. So 1 minus 3679 is 0.6321. Now, in how many packets we get defective? Sorry, that is n into p of x is equal to 3000 into 0.6321 is equal to. So 3000 into 0.6321 is equal to 1896.3, approximately 1896. So out of 3000 packets, in 1896 packets we get defective screws.